Okay, in the last question on this Core 3 paper, we're dealing with the graph of this particular function. They could have asked you to sketch this yourself, showing its asymptotes and intercepts using transformations, but they've been kind. They've given you the sketch. For part A, you don't really need to look at the sketch very much at all. You've just got to apply standard rules to get this integral here. No tricks needed. If you look over the rest of the paper, your integration by parts and by substitution has already been examined. So this is plain integration using the rules, and a dot e2 is taking that limit, that integral, and plugging in these limits. You may have to do some simplification of logs, or maybe not. They tell you the answer. You need to get convincingly to that expression. In B, we really are back to the graph. So we've got to get the y-coordinate of A and the x-coordinate of B. And of course, these are the x and y intercepts. So at A, you can take x to be a particular value. At B, y is a particular value. The equation of the curve is given at the top. So you should be able to get these two coordinates. In the case of B, they tell you the answer, which is useful, because if you can't do that question properly, at least you've got the answer when you need it, which you do in part C. Because in part C we need an equation of a normal. It's the equation of a line, so we need a point, which are going to be the coordinates of B, which effectively you've been told, even if you couldn't get them yourself. And then you need a gradient. With a point and a gradient, you can use the y minus y1 recipe. The gradient of the normal, well, your starting point is the gradient of the curve. There's the curve. You find its gradient by differentiation, put the right x value in, but then you want the gradient of the normal, so you do your standard trick to find the gradient of the normal, set up the equation of that normal, and that gets you 4 marks. In part D, we need to find the area of a region, and this ties together very commonly. Part D rests on earlier parts. This ties together answers you've already got. So we've done a definite integral in a dot e2, and that corresponds to a particular area on your sketch, which you may want to shade in. But it's not quite the area we want. We want the area of the region enclosed by the curve, the normal to the curve that you found in B. Now that may not be on the sketch yet, so you need to, at B, draw a line to be the normal. And the other boundary is the y-axis. So get the normal drawn in and shade the complete area, which is not just this bit here, but is related to it, and work it out, probably in 2 parts. You should be able to see the relevance of the answer for a dot e2, and having got the equation of the normal, you should be able to algebraically find any other points that you need on the diagram you've drawn. So get a decent sketch including the normal, visualize the area you want, and I think it's going to be an integral that you know the answer to, plus a triangle that you need to set up. But draw your own diagram, see what you think.